Hello, do you hear me?
Miglena?
Yes, it's Miglena. I just wanted to check the audio. Okay, thank you.
Sì, puoi share screen per essere pronta?
Hello.
Hello.
I'm back again.
Carlo.
I'm trying to...
Bravo. And the full screen.
Yes. Now it's okay.
Yes. Questa volta tutto è a posto.
Sì. Ok. A chance.
Miglena, press please full screen. This the National Archaeological Institute and Museum is an academy.
Can you see it now, the presentation?
I can see you, not the presentation.
Hello again.
Yeah.
Can you see it now?
The PowerPoint, yes, you know.
Yeah, okay.
Yes, it's okay. It's okay.
It's okay now? It's moving?
Yeah, it's still on little screen, but it's visible.
Can we start?
Okay, let's start.
Yes, okay. Yeah.
Good afternoon, colleagues. First of all, we would like to thank organizers for this conference dedicated to Fibulae. My PhD thesis was on Fibulae in ancient trace from pre-Roman period. So it is really great pleasure to participate in this conference. I would like to draw your attention to another topic, very interesting one according to me, maybe to provoke some thoughts and discussion after my presentation. So in the last few years, archaeologists have begun paying more attention to the life cycle of single artifacts, starting from their production, exchange, use life, deposition, etc. Such study facilitates dating the closed complexes, for example, graves, that refer usually to the time of the making of the artifact or the time of its deposition. Traceological analysis, also known as use-wear analysis or metalwork wear analysis, provides important clues about determining the duration, type, and intensity of use. It examines invisibly traces on the surface of the metal artifact by optical microscope. These traces can reflect the actions performed on the object during its production, use, and deposition, as well as during the post-depositional processes and conservation. The traceological studies of metal artifacts were developed much later than the lithic microwear research, which has been extensively studied in the past 40 years. The reasons for this delay are various and include the possible corrosion processes, recycling, traces from the conservation, etc. In this sense, gold is very suitable metal for such type of analysis because unlike copper alloys, its surface is not affected by oxidation and corrosion. The great challenge in this kind of study is to link the observed macroscopic and microscopic traces on the metal surface to a proper action, such as manufacturing, utilization, or post-deposition. Fibulae are very often used as reliable chronological markers that creates the need to refine their chronology as precisely as possible. Their use life can be different and depends on the shape, size, and material they were made of. Some fibulae had long use life. Others had a practical purpose in addition to the decorative one. And another group, the third one, mainly goat, had primarily decorative function. Goat fibulae were extremely rare and were a sign of authority and wealth.
Can you change the slides, please?
They are not changing?
No. Now, okay.
Now it's okay?
Yes.
Okay. The presented research aims to study through different analyses, XRF and optical microscopy, the life cycle of 6 goat fibulae, part of the permanent exhibition of the National Archaeological Institute with Museum in Sofia. They display quite different cases of use life. 2 of the fibulae, these ones, are bilateral and were discovered as a pair in a brick grave in Tumulus II near the city of Pseutopolis. The excavations were carried on in 1949. The burial rite was inhumation of a young girl. According to the researchers, a goat necklace, a goat medallion, 2 silver Thracian type fibulae, a silver and 2 iron bilateral fibulae, an iron ring, clay unguentaria, and a labostron were found in the grave. Unfortunately, not all objects have been published. Both bilateral fibulae are extremely small in size, 1 centimeter and 1.7 centimeters long. They were made of a single goat wire that passed to the bow into a flat leaf-shaped plate. The bilateral spring has 10 coils and an external cord. The upper part of the foot consists of 2 parallel non-functional bilateral springs and an external cord as well. Its end is shaped as a decorative number 8. They can be dated to the end of the beginning of the 2nd quarter of the 3rd century BC. The bilateral fibulae with a non-functional spring at the end of the foot are the most popular lateen brooches in ancient Thrace. They feature great variety of size, shape, and cross-section of the bow that gives grounds to assume their production in local workshops. The presented fibulae have been studied through an X-ray fluorescence spectrometer at the Laboratory of Conservation and Restoration of the National Archaeological Institute with Museum in Sofia. Concentration of gold, silver, and copper are determined, but for the moment we can present them only as preliminary. The concentration of gold is identical, 91.8 and 91.6%. The amount of silver is almost the same as well, 6.8 and 7.2%. The percentage of copper is 1.4 and 1.1%. Copper in amount of up to 2 or 3% is considered the maximum limit for natural impurities. Therefore, it can be assumed the gold is natural. On the basis of the very close results, we can conclude that both fibulae were prepared in one workshop from the same natural gold source without intentional addition of silver or copper. Both bilateral fibulae have been examined using a digital optical microscope. As a reference point in the study, microscopic investigation of a contemporary 14-karat goat wedding ring worn for 5 years was used. On its surface, two types of traces were observed. The dense and fine parallel scratches could be associated with the mechanical polishing during the manufacturing, while the deeper lines with varying width and direction could be interpreted as resulting from the intensive use. The first bilateral fibula does not bear traces of usage on the inner part of the catch plate. More traces could be linked to the production process. The cord of both fibulae feature line that spiral along the length of the wire, these ones. They testify that the very common in the Hellenistic period strip twisting technique was used. Narrow strips were cut from sheet, then were made round by twisting and then rotating them between two flat surfaces. On the lower part of the catch plate, dense layering of excess gold is visible. It is a result of the hammering of the fibula. Some parallel shallow scratches can be seen on the upper part of the bow and can be interpreted as traces of mechanical polishing. Only some traces of a contemporary, maybe, intervention can be seen on the lower part of the bow. They are tight, bright, and seem fresh. The second fibula has deformed functional and non-functional springs and decorative element in the shape of number 8. Very interesting are the densely deep parallel lines visible just on the inner edge of the catch plate. They can be interpreted as marks from the catch of the end of the pin. The performed observations provide clear evidence that there are no signs of intensive use of both fibulae. This is supported by the small sizes of the specimens. All this leads to conclusion that these miniature fibulae were made specifically for the burial and were not used in the real life. In this case, we can connect the date of the fibulae with the date of their deposition in the grave. The next studied group is represented by 4 gold crossbow fibulae. They became part of the collection of the National Archaeological Museum in the beginning of the 20th century as stray finds and purchases with a known context of provenience. This late Roman type of fibulae had been worn by military officers and members of imperial administration as a sign of rank and status. They can be dated to the end of the first half of the 4th century AD. 3 of the gold fibulae are very similar. Their length is between 7.2 and 7.8 centimeters. They feature a massive bow cast probably in multiple use stone mold or by lost wax process, while the other parts are made separately by hammering. The transverse bar is a hexagonal hollow tube where the pin was attached to the body of the fibula by a thin rod. 3 bulbous knobs with pointed tip are attached to the both ends and the center of the faceted crossbar. The places of the joining of the foot and the 3 bulbous knobs were fitted with a decorative collar with small granules. All specimens feature decoration on the foot, incised lunulas and volutes. The 3rd fibula feature engraved ornaments by Niello on the crest of the bow and on the center of the foot. 2 of the fibulae have bronze pins. As expected, the fibulae, which are identical in size and decoration, display very close chemical composition with respectively 96.2% and 96.9% gold and 3.8 and 3.1% silver. The composition of the third fibula with yellow decoration is a little bit different. The fourth gold fibula is smaller with 4.4 centimeters length. The center of the bow is decorated with a linear pattern with yellow inlay. On the foot, 6 deep incised lines have been executed. The XRF analysis displays amounts of gold, silver, and copper. The microscopic examination of the presented crossbow fibulae shows different traces on the surface. Some of them could be connected to the production processes. The inner part of the bow is rough, probably resulting from the chisel. Several small and shallow triangular traces originate from the lunulus. Some of them can be the result of slipping out line, and others probably indicate where the decoration should be applied. Traces of a rasp and a dapping punch tool are visible between some of the ornaments. On one of the fibulae, a small gold plate was put on a crack on the place of soldering of the knob, forming a sort of patch. At some places, traces of layering of gold are visible. Shallow parallel dense lines are a result of the mechanical polishing at the end of the production process. Some traces associated with the use can also be established. The bronze pins of 2 of the fibulae, which most probably replaced the gold ones, are clear signs of the intensive use. Below the patina of on one of the bronze pins, long scratches are visible. Interesting are some scratches that pass over the yellow lines. The rough surface and the circles copied in a row here with yellow decoration on the foot of the third fibula could be linked to the post-depositional process, probably a contact with an organic matter at high temperature. Several fresh scratches in the inner part of the catch plate could be interpreted as a result of a present-day cleaning from the soil. In conclusion, the presented results from the microscopic analysis in a combination with other interdisciplinary methods are a novel approach to further develop the standard archaeological methods. 2 very different cases of used life have been observed. In the first case, the fine gold fibulae were specifically made for the deceased female, most probably immediately before the burial. In the second case, prolonged use, also evidenced by the massiveness and significance of the objects, can be seen. At the present, we are unable to determine how long had the artifacts been used. Maybe future additional experimental studies would shed more light on this matter. Thank you very much.
Thank you very much, Miglena Stamberova, for the very interesting presentation.
I hope that you were able to see these lines and scratches. Because the presentation was not in full screen.
Have we some minutes for discussion? I have a question, if I may.
Yeah, sure, sure.
Congratulations, I found very interesting your presentation, and especially for me, because of my presentation for yesterday, you said that among the fibulae there aren't miniature fibulae.
Yes.
Made especially for for burial use.
Yes, most probably, yes.
That is because of the size, because very small.
Also because of the size, but this is not the big reason for this conclusion, but because of the lack of traces, visible traces of use on the inner part of the catch plate.
Thank you. And another question about the value of the gold. I studied in my studies for my presentation that the value of gold in the Greek antiquity was depending of the silver as well.
Mm-hmm.
Can you say something about it?
Well, we are in the beginning of accumulation of data about gold in the amount of gold in gold objects. You know that there are certain amounts when we can define a certain object made of gold or made of electrum. But the percentage of silver for electrum is a little bit higher, more than these amounts.
Oh, thank you.
Okay.
Are other questions, because I cannot see?
Okay, I will stop sharing then. Thank you too.
Thank you, Milena. Thank you very much.
Thank you.